Hi everyone, welcome back to Mr. Carlson's lab and the continuing CR88 receiver restoration. In the previous episode, these capacitors all got installed, so these are replacing the bathtub capacitors that were screwed down to the chassis here, so all these yellow capacitors that you see have all been replaced. Now it's time to replace the main filter capacitor. Now, this main filter capacitor still works and it is in very good condition. I've started the radio up a few times and it seems to be absolutely fine, but it cannot be trusted just like the bathtub capacitors. This has to be taken out of circuit. Now, I don't want this thing to leak in the future because these have, fluid inside them. The seals on the bottom side of the capacitor are all still good and I want to keep it that way. So what I'm going to do is I'm going to install some very nice poly capacitors on the bottom side of the chassis. You see that there with the light glaring on it. So there'll be 3 of these capacitors installed to replace this one here. That should be a nice long-term solution, keeping the electrolytic capacitors out of here. Now, again, what happens with these capacitors is they end up trying to turn into resistors and they end up getting hot inside due to internal leakage, electrical leakage. And then what they do is when they get hot is they build up pressure and then they blow fluid out around the seals on the bottom side of the capacitor. Now this capacitor is still in very nice condition. There's 0 leakage with this capacitor because it hasn't done that. All the seals are fine. So now is the time to get this thing out of circuit and just have it there. So this here is just going to remain on the top of the chassis for aesthetic reasons. It'll be completely unhooked. And the new capacitors will be installed right down here, right on L49 and L50, the 2 reactors on the chassis here. So in order to show you how I'm going to do this, I will have to focus on these pieces of paper here. So I'll move the camera and I'll be right back. This drawing of the underside of the chassis here, so somewhat of a wire out, not so much a schematic, but a wire out, can be found under the CR88 manual. You'll notice that many AR88 manuals do not have this. So if you have an AR88 and you're trying to find this kind of stuff, L49 and L50 and the capacitor and all that stuff, just look at the CR88 manual and you'll find the information in there. So that might be a little bit of a handy tip for all of you there. Oh, and by the way, if you're just joining in now and you're following along on this receiver restoration, if you want to see the earlier parts of this restoration, just look under the Show More tab under the video's description. So tap the Show More tab and it'll expand the video's description and you'll see part 1, part 2, part 3, and so on underneath there. All right. So what I need to do is replace this capacitor right here. So they make this a little bit tricky the way that they do this. They could actually have just drawn the capacitors in here, but I'll show you exactly how the capacitors are attached here. So first of all, if we look at the schematic itself, these here, I don't know if I'm going to be able to get close enough. You're going to see this okay. I hope I can. I'll just extend this about as far as it'll go. That's as far as it goes. Okay, so 1, 2, 3. These are the 3 filter capacitors that are inside this right here, okay, which is in that top corner of the chassis. Now you'll notice with these 2 capacitors here, you'll notice that there's 1 capacitor attached to each side of L50. Okay, so that's pretty easy to locate. So 1 capacitor here and 1 capacitor here, and you'll notice that they both connect down here. All right, and then that runs over to the center tap of the transformer. You'll notice on the center tap line that we have some resistors that go to the actual chassis ground. This is to establish bias. So what they're doing is they're lifting the center tap above ground to give a negative voltage to the control grid of the 6K6 and I believe the 6SJ7 if I remember correctly. So let's see here, I'll have to follow the control grid line here. So it runs up over here and then down here, yeah. So they're establishing bias for both of these tubes by putting this resistor divider here. The values of this divider are pretty crucial. If you change the values of these dividers, the biases will change on these tubes. So anyways, that's something to keep in mind there. So make sure that these resistors are okay as well. So back to the capacitor here, you'll see that we have 1 cap here, 1 cap here. So there's 1 lead here on each side of L50. And then these 2 leads connect together and go to the center tap of the transformer. So technically, we have 3 leads here. This lead, and since these are connected, we have 1 lead here. This capacitor here, this filter is standalone. So 1 lead goes directly to chassis ground, and then we have the other lead which runs off to the other side of L49. Okay. So now, before I actually located this, I drew this up. So this might benefit you if you're looking at the bottom portion of the chassis here. So C96 and C97 are the capacitors that run from here, and then they connect together, and then this runs off to ground. Now you'll see that there's a number 3, a number 5, and a number 4 here. Those are the numbers on the bottom of the capacitor. So if you look up here, pardon the shaking of the camera as I'm moving things around here, you'll notice that there's numbers on the bottom side of the capacitor here. So you'll see 3, 4, 1, 2, and then this would be 5 right here, right? So, again, following in line with what we're looking at down on the actual sheet down here. So, you see over here, I zoom on in again, lots of movement here, pardon the camera shaking and all that. So you can see that corresponds with the numbers right here, right? So now, if we were to say, you know, you wanted to actually, I guess you could say, rebuild this capacitor. Some people do want to do that. I'm not going to bother with that because of what is in that capacitor. So I'll just move over here and grab this pen, which is hiding out of the way. So technically, if we look at this, we see 1 and 2, okay? So 1 and 2 are the capacitor on its own, C98, which is this capacitor right here, C98. We have the ground, and then that runs up to L49, right? So we have the ground, and that runs up to L49. So technically, in this capacitor block, we have 1 capacitor that is doing this right here. So that's 1 cap right there. Now, if we look back to here, we can see number 4 runs off to the center tap. Okay, so this is the center tap that runs off to that resistor divider, and it's lifting the center tap off of ground to establish the negative bias. So we can see that we have number 4 here. You'll see that we have 2 wires here. Now you can see where it says C96, C97 by number 4. All right, and then we have C96 and C97 by 5. So if we see C97, 5, and then we see C96, number 3, right? And then we see the 2 that are joined. So that's how they've coded this, which is kind of cryptic. All right, so if you wanted to draw the capacitors in here, it would look like, pardon the fuzziness for a moment here as I draw these in. All right, so we have from number 3 to number 4, because number 4 is our ground, right? You see we have number 4 is a center tap. Okay, and we have number 3, which runs to one side of the reactor, which is L50, and 5. So that's how the capacitors look inside this block. So that might make things a whole lot easier for you if you were, say, going to try and rebuild this thing. That's what they look like inside. We have 1 capacitor from here to here, 1 from here to here, and here. So this technically is the center tap. That one there runs to the center tap. And then, you know, so on and so forth. All right. Now, this can very easily be verified. Again, before I found this, I did this all with tracing this with a multimeter. And if you'd like to know the process of that, I'll just quickly show that to you. All you do is you look for, so I've got this right now, I've just got this on continuity. So when I join the leads, it'll beep, okay? So I'll just move this up here so you can kind of see what I'm doing. Hopefully I can get all of this in here. I guess that doesn't really matter. You'll hear it beep anyways. So, looking at the actual schematic, you're going to be able to view this. There's going to be lots of moving in and out here. So you'll see the rectifier. all right, you'll see number 2 runs off to this portion of L50, all right, and we also know the capacitor's there. So we know that pin 2, that's a known location, okay? So this is the rectifier tube, so we know that pin 2 is going to connect to C96, one side of C96, which is one side of L50, okay? So what we would do is we would locate the rectifier tube and locate pin 2. This is the rectifier here, and then this is pin 2, okay? So then what we would end up doing is just touching these until we find a connection. So we know that pin 2 is now connecting to number 3 on this capacitor, okay? All right, so then we can look at this here. So we can see the rectifier is connecting to number 3 very, very easily, right? So this here, number 2, you can see me pointing here, I'm doing this on camera, pin number 2 runs up here and then connects to pin number 3. This would be pin number 3 of the capacitor, and so on and so forth. And you just go through and you just trace things out like that. Another thing is you'll see that they kind of wire this odd. So you can see that L50 attaches directly to L49, and then on the other side of L49 is C98, and as you can see, number 2. So basically, if I go to here and I go to number 2, right, you can see that. You can see that up there, right? Of course, we have number 1, which is just chassis ground. It's this one right here. You can see it's just tied off to the chassis, and so on and so forth. So I just traced everything out. Of course, did this all the hard way until I found this, and it was just good verification at any rate to make sure that what I had drawn was correct, and it is. So everything was traced out okay. So you can see I've got 2 capacitors here and 1 capacitor off of here. They join L50 to back to L49 like this over here. So what I need to do is I need to put a standoff under here to mount a bunch of these new capacitors. So if I'm looking at the bottom portion of the chassis here, another little tip or trick if you're looking at transformer wiring. So these are the plates of the rectifier tube here. Okay, so these are going to be the plates, and this is going to be the center tap. What they do is they put the center tap lug between the plates, because this is the end of the winding. So we have one end of the winding, the other end of the winding, and this is the center tap of the winding. So, and the center tap of the winding attaches to number 4, which is this one here. So again, if I was to verify that by touching this to number 4, as you can see, right? So that is our center tap. So now what I need to do is put a capacitor from here down to the center tap and a capacitor from here down to the center tap, and then I need to install 1 capacitor from this side just to the chassis ground. So what I'm thinking of doing is putting a standoff. You see that little mounting screw here for the transformer, so that's how they screw the transformer to the chassis. Putting a standoff here, because again, the ground for those 2 capacitors is isolated. Remember, it's lifted from the chassis ground in order to establish bias. So what I was going to do is mount 1 capacitor here and 1 capacitor here, and then tie the legs to a standoff down here, and then a wire will run from the standoff right over here to the center tap on the transformer. Now there's a bunch of bonuses to this as well. You know, we're shortening up leads. So the leads that are, you know, running from the capacitors basically right at the inductor, and then they run right to the center tap, which is perfect. And of course the grounds for the transformer are all around in this area, so it's perfect to have everything grounded in here. So we might even see a slight reduction in hum. We may or may not. So, because you got to remember, they're running the filter can all the way up to the top here, right? So, you know, everything is getting run off from down here, but the filter can is way far away. So by having the caps right directly, you know, at the reactor is definitely a bonus. So we'll get the capacitors installed here, and once the caps are installed, I'll be back and we'll go after some tubes. We'll check the tubes, and then we'll power it up again and see if the thing receives any better than it did in the previous episode. And then, of course, if it isn't, we'll troubleshoot our way to success will make everything work out just the way it's supposed to. The new poly capacitors are installed here, here, and here. So there's a terminal tie strip that stands off the chassis. It's kind of hard to see it from the camera angle, but the chassis is down here, and if I touch the top of this terminal tie strip, it's about that high off the chassis. So the terminal tie strip is very long. So these capacitors have to be suspended above the wiring harness, so this goes quite a ways down to the chassis. The terminal tie strip itself is fastened to the transformer screw. Again, this point is insulated because there's a negative voltage here, and that runs off to the center tap of the transformer here, which again supplies bias for the two audio tubes and the RF gain control, things like that. Now, these capacitors are not electrically polarized, so you can put them in circuit either way. I prefer to have the outermost foil attached to the ground side. So it's just common knowledge when you're restoring something like this, if you're installing any of these capacitors, the outermost foil is always attached to the lower impedance portion of the circuit. In this case, I'm just keeping the outer shell of these as close to ground as possible. They are suspended above wiring harnesses here and everything as well. You'll notice that this side is tied to ground over here, yet the writing on this capacitor is backwards. That's because this is the outside foil end on this capacitor, and this is the outside foil end on these two capacitors. This just further goes to show you that these things run down the line any old way, and they don't mark the outside foil. So this is attached here to a standoff, again, to another transformer mounting lug over here. The reason this is stood high up, this is about that far off the chassis here, and the ground lug is here, again, is because this is suspended over the wiring harness. So this end of the capacitor ties to the filter reactor here, and then these two ends of the capacitors tie to each side of the filter reactor over here. And this is the brand new filtering capacitors for this. That replaces that huge can on top, and that should be good for an extremely long time. So again, you know, they're not electrolytic, so they should definitely last the duration. If we take a look at the old filter capacitor, it's completely disconnected from circuit here. Pardon the camera movement. I'll move some things around here and zoom on in. It's about as close as I can get. Maybe I can get the whole can in there. I can. I'll try and keep the wiring harness there in there. So we take a look up here. You can see that the capacitor is, you know, completely disconnected. The other two terminals down at the bottom here are disconnected as well. Down here, disconnected. So what I've done is where these two leads here joined, I just joined them. They're disconnected from the capacitor. I've joined them and put heat shrink on them. And the leads that have been removed from the terminals, like from this one, and the two bottom ones, all have heat shrink on them. So the wire ends here, and then the rest is just heat shrink out to the end. And then I've zap strapped the wires back into the harness again. So the main filter capacitor in here is just for looks. This is just a ground that runs to the chassis ground, so I left that hooked up. There's no harm in doing that whatsoever. So this old capacitor is completely out of circuit, and there's absolutely no worries about that thing anymore. You'll notice that I just trimmed the wires. Usually what I do, just for aesthetic reasons, is I like to clean these off so the lugs look fresh. In this case, I didn't do that because I didn't want to heat any of these lugs up at all. Again, any type of heating could cause this to try to leak physically, and I don't want to do that. So I just carefully trimmed the wires off, and I just left the remnants there. So that's it for the filter capacitor install. So now what we'll do is we'll take a look at the top side of the chassis and test some tubes. And if we find some bad tubes, we'll replace them, and we'll try the thing out and see if we have any improvements from this point on. Let's test the 6SG7 tubes first. There's a whole lot of them in here. So 6SG7, so 3, 6.3, 19, so 3, 6.3, 19, and let's see here, DFH goes to the top, so D, F, and H. I'm looking at this from the side, so C, E, and G go down, C, E, and G go down. Okay, now we're ready to plug a tube into this socket right here. So let's take this one out and see what it does. It's the one with the W on the top. Okay, so line set is still good. It is. All right. So now I just got to wait a few moments until the tube heats up, and we'll see what condition this thing is in. All right. That's already not looking very good, is it? It's ever so slowly creeping up. Should be much better than that. We're in the questionable area. Maybe that W does stand for weak. That's not looking good. So that one's out of there. It's the first RF amplifier. Let's go for the second RF amplifier. Another one in here with a W on it. Weak possibly as well. Maybe looking for some 6SG7s by the looks of it. So right now what's happening is inside this metal case, the filament is lighting up and it's heating up the cathode sleeve. So there's a filament like in a light bulb and it's heating up a pipe, and that pipe has to glow orange before the tube comes into emission. That's why it takes a little while for these radios to come on. Boy, this one is, I'm telling you, that's coming into the green area, but not all that great. It's moving up. Might just need a bit of time. The line test is slightly low on the line. So in the camera, you're off to the side, so it looks like it's over this way. If I bump the line test up one more, it's still within the black area. It's just closer to the top. That might give me a filament that's a little bit closer to what it is, so that might actually help out just a touch. Give me a bit better of a reading. Yeah, so it's in the good area. All right, well, that one is okay. I wouldn't say that it's great. Let's try this other one with a W on it. Wouldn't it be something if every single tube in this unit was tired? Another thing to keep in mind when you're using one of these testers with a line set, if you set the line set up and then you plug a tube in and then it drops right down, that's the reason that you can compensate with the line. So you want that to, you want it within that little black margin area there. Of course, closer to the top will make the filament voltage a little bit more accurate, more correct. If it's low, it's seeing a lower filament voltage than what the radio receiver is providing. So, of course, the differences on here will be marginal at that point, but wow, this radio is just full of them. After testing a few tubes from the radio receiver and getting questionable results, I figure I'm going to go and grab some new tubes from my tube stock and compare. So I've got some brand new 6SG7s right here. So they usually come out of the back side, which they do. All right, 6SG7, Westinghouse Premium, code Q and T. And we can see the code Q and T, so I can be pretty sure that is a brand new tube. So let's see how stingy my tester is. So looking at the needle, it's right dead center of that little black block. All right, so the way the camera is, it makes the needle look like it's pushed over this way a little bit, but it's actually perfectly centered. So let's see how this is going to test. So here we go. A little bit of movement that you see there is the heating system coming on in here. All right. There we go. That is a brand new tube. So it's just into the good area. Now, one of the things about these testers, as I've mentioned before, is if a tube ever pins the needle off to the 100% side, so if it goes right to the end, or it goes right, to 100 or past, that makes the tube questionable. Usually there's something wrong with them inside. As long as they're within the green area, they are good. All right. So, and that one is no problems there. Okay, so brand new tube. So I'll put this one as the first RF amplifier. I think I'll replace this one as well. So I'll put a brand new tube in there. So I'll grab another 6SG7. Let's test this one. Oops, wrong side. Again, they usually come out of the back side of the box. Tell these boxes have been around for a while. Looks like other people have looked at it. All right, Sylvania, 6SG7. And let's see what this one does. All right. So what I'm going to do is I'm just going to go through the rest of the receiver and test all of the tubes. And once I have all of that done, I'll be back here and we'll try the receiver out and see how well it performs. I have to get rid of this glass mixer tube and things like that for sure. So let's test this one out. No problems. It's in the green area. Again, 2 brand new tubes and just in the green area. It's very common for these tube testers to be like that. So 2 brand new RF amps. This thing should receive like crazy. So now I've got to replace this one. I'm going to test the oscillator and go through all the rest of them, and I'll be back. And again, we'll see how the thing performs with new tubes and new capacitors. That should be exciting. And much later, almost every tube in this radio receiver is replaced just because they were all pretty questionable. The regulator is still very good, and that was pretty much it. So this is the only tube that really remains in here. Every other tube is replaced. And when I say this regulator is good, it's really good. Better than some of the new ones that I have. So anyways, you can see all the mess of all the tubes and all the open boxes. So lots and lots of tubes being tested. And that is the result right there. So what I'm going to do now is get this thing attached to an antenna and to a speaker. We'll take a listen and see how much of a difference that makes. All right, let's see if this thing receives. So I've set it about center of the AM broadcast band. I have it on the AM broadcast. RF gain is up, audio is down. This knob needs to be adjusted. It's pointed to the wrong area, but it's down. I just have this pointed to adjust. I don't know where the antenna trim is going to be. The tone should be, relatively high frequency. And yeah, everything is set up. So we're on AVC and no noise limiter, so this doesn't matter. The BFO is off. And crystal phasing, let's leave it where it is. So let's turn it on and see what happens. So receive modulation is what we want to try first. So I'll turn this on. It's a good sign. The regulator is glowing. Let's let it warm up. That is quiet. Boy, those new filters, wow, there is nothing coming out of that speaker. It's very nice. Wow, look at how much audio gain it has. I'm just touching. This is down at the stop. Keep in mind the knob's pointed to the wrong area. It should be pointed over here, but wow, lots of gain.
34 bucks. Don't take it away. And I want to talk to you about myths around beating it.
OAC. Interest accrues 12 months after installation. Conditions apply. See website for details.
Have to take it first.
Nice thing about the tuning on this is it is as smooth as glass too. I haven't even done anything to the tuning, haven't lubricated it or anything, and it's just so smooth. So I can imagine this is going to be, once this is lubricated and grease is put in here, of course the whole face has to be removed and everything yet. I'm going to replace this. So, it'll be like velvet at that point. It's so smooth right now. It's just amazing. So if you own an AR88 or a CR88, it should be velvet smooth. It's so smooth right now. You don't feel any gearing or anything. It's just very, very smooth. You wouldn't even know that there's gears in there. You'd think it's almost like a belt drive. It's so smooth. I'm hearing some static in here. I'm also seeing the regulator flicker a little bit. So that's either a draw on the high voltage or the actual regulator is doing that. That was the only tube I didn't replace and it tested strong, so I have a feeling there might be an intermittent, maybe one of the micas is going away or something like that. Can you hear that? Can you hear that in there? It just gives us something else to troubleshoot. We'll find that. Okay, turn the volume up, override that.
Today, I'm sure we're going to be talking about the trade deadline and what, if any, moves.
We're going to take a break for the weekend, and when we come back, the lesson is entitled Esther Becomes Queen. Esther.
Being shrouded in the heart of darkness. And that means also making sure that the voices on the ground...
Conditions of BC.
Wow, all I have to say is it's receiving like crazy just with that alone. So let's try another band. Let's go up to number 2. It's alive. Number 3 is alive. Number 4. Number 5 is dead silent. So number 5 is quiet. We'll have to find out why number 5 is quiet. So it could be stopped oscillator or maybe a coil or something. Who knows? We'll find out. And let's try turn the volume back down again. Go to 6. And 6 is alive. All right, so we have to troubleshoot number 5 and find out what that popping and crackling noise is. So there's some form of static or something. Something might be trying to short. Maybe one of the mica capacitors is going away. You can hear it there. It's doing it again. Yeah. Ever so subtle. Nice thing about the super probe is that it'll find that part no problems. It'll find it really quick. So whatever method we use, but the super probe would work very, very well for that. Other than that, the BFO, we can try the BFO, see if the BFO works. Let's see if that happens. We'll go down back to the broadcast band. So there is a station there, so...
For you, for your teammate, carefully searching the market, dozens of major carriers to find you the best fit. That's it. No more stress.
Nothing.
No more confusion. The First Mark team has spent the last 30...
So no BFO either. So we'll have to troubleshoot the beat frequency oscillator. So there we have it. So we have 3 things to look for, and then it's ready for tuning. So I think in the next episode, we'll get all the problems done, and then it'll be alignment, and it'll be ready to try out. So it's already working very, very well. It's just got a few minor things that we're going to troubleshoot together and find. If you're enjoying my videos and the Grand Receiver Restoration Series, you can let me know by giving me a big thumbs up and hang around. If you're new to the channel and you enjoy this content, don't forget to subscribe and hit the bell symbol so that way you get notified as soon as I post a brand new video. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way and gaining access to many of my personal electronic inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comment section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.